Hey everybody. All right, we're going to be reviewing equations and inequalities for our chapter test. Right now, what I'd like you to do is write our goal over here. And what is always our goal when we are solving equations and inequalities? Remember, the goal is to isolate the variable by using inverse operations. Isolate the variable means get it all by itself by doing the opposite, the inverse operation. Okay, remember it's all about the process. Okay, so let me just zoom out here. You can see I've put a big X, or I guess a plus sign, and this quadrant is addition, subtraction, multiplication, and division. Okay, so and it's all about the process. You guys know I'm pretty strict on this. Your algebra teachers will thank me. You will thank me when you get to algebra. Okay, so if I have an addition equation, I have 4 plus x equals 29. I want to isolate the variable, get x by itself, by getting rid of 4. So I'm going to use the additive inverse. So 4 minus 4, and what I do on one side, I have to do on the other to keep those scales even. So 4 take away 4 is 0. 0 plus x is x. 29 minus 4, x is 25. Checking. You must check it. Replace x with what you're telling me it is. So if x is 25, then you would say 4 plus 25 equals 29. This step is crucial. 29 equals 29. Solve it. Don't just write it. Solve it. 29 equals 29. Check. Circle. Okay, subtraction. If I have y minus 6 equals 32, I am going to isolate y. I'm going to get it all by itself by getting rid of this minus 6. What is the additive inverse? Plus 6. So I'm going to add 6 to both sides. 6 minus 6 is 0. Y plus 0 is y. 32 plus 6 is 38. And then checking, if y is 38, then I would write 38 minus 6 equals 32. Do this final step. It's very important. I know it doesn't seem like it now, but trust me, it is. 32 equals 32. All right, now let's do multiplication. I chose a hard one because they're really, you know what to do. So even though it's a fraction, you still work the process. So I have 3/4 t equals 3. Okay, this is multiplication, so the inverse operation would be division. So I just drew a giant fraction bar. So 3/4 divided by 3/4, because I know it's going to be 1. Over here, I'm going to go ahead and write it like a division sentence. 3 divided by 3/4. And what is my algorithm when I'm dividing fractions? Keep, change, flip. So now I have 3, which is always 3 over 1, times 4 over 3. Cancel, cancel. I've got 4 left. Okay, so now to check it, always check. Okay, if you're telling me t is 4, then 3/4 t, 3/4 times 4 equals 3, equals 3. So this is 4 over 1. 4 divided by 4 is 1. 1 times 3 is 3. 3 equals 3. Check. We got it. Now let's do division. D divided by 6 equals 2. What is the operation that's going on here? Division. How do I undo it? Multiplication. I've got to multiply by something that I can cancel against this 6. So I'm going to multiply by 6. What I do to one side, I got to do to the other. So 6 is really 6 over 1, remember? So 6 divided by 6 is 1. 1 times d is d. Okay, 2 times 6 is 12. So if d equals 12, here I'm checking it. If d is 12, then d would be 12 divided by 6 equals 2. 12 over 6 is 2. 2 equals 2. Check. Okay, now I want you to pause the video, copy these down. I want you to solve them and check them. Solve them, check. Solve, check. Solve, check. Use the process. Okay. All right, so the next little bit that we're going to cover is inequalities. And I feel like you guys are pretty good with the number lines. Some of you, be sure you look at the number line on the wall If you get a little, if you think you might have the numbers backwards, because I noticed some of you, that's what the problem was. But the biggest issue is in understanding what these words mean. So I've got 10 cookies here as my example, and my variable C for cookies. So if I want no more than 10 cookies, if your mom says you cannot have any more than 10 cookies, wouldn't that be the same thing as less than 10? Because you could have 8 or 9, and you could have 10. So you've got to have that equal part. But you cannot have 11. And the way I check it is I do a number line, and I'm saying, if I have no more than cookies, could I have 5? Yes. Could I have 10? Yes. Could I have 15? No. So that's just another way that I verify that I'm going to have a closed circle here because it's less than or equal to, and my arrow is going to go to the left, less than, because this is where I have my checks. Okay, the next one. If your mother says you must eat at least 10 cookies, well, could you eat 10? Yes. Could you eat 11? Yes. Could you eat 15? Yes. At least is the lower minimum. At least 10 cookies means no less than 10. So that would translate into meaning greater than or equal to. And here I have a number line. Could 5 cookies do if your mother says you must eat at least 10? No. Would 10 do? Yes. 15? Yes. And on and on. All of these values over here would make this a true statement. So I'm going to have a closed circle here because I've got greater than or equal to, and I'm going to go off to the right. Okay? What if your mother says you must eat a minimum of 10 cookies? That's the same thing as saying at least. A minimum of 10 cookies. That's the lower boundary. You must eat more than 10 cookies. So, looking at your number line, it's virtually the same as this one. Okay? If your mother says, oh, you must have a maximum of 10 cookies. Maximum is the upper boundary. It means you cannot have any more than 10. But can you have 10? Yes. So there you have the equal sign. Could you have 5? Yes. Could you have 10? Yes. Could you have 15? No, not if your mother says you can have a maximum of 10. Okay, so that's C less than or equal to 10, which is graphed just like that. All right, folks, you want to review your foldable, and I think you'll be good to go for the quiz or for the test. Thank you. Bye-bye.